So the sixth identity would be x plus y the whole cube. So x plus y the whole cube is x plus y into x plus y into x plus y. So that can be written as x plus y into x plus y the whole square. So when I expand x plus y the whole square, I get x plus x square plus 2xy plus y square. So this is x times x plus y the whole square plus y times x plus y the whole square. Now when I multiply each of the terms with x, I'll get x cube 2x square y xy square plus x square y. Multiplying each of the terms with y, I get x square y 2xy square plus y cube. So I have x cube 2x square y and I have 1x square y here. So that will be 3x square y, and I have a xy square here and I have a 2xy square here. So they both add to 3xy square and I have a y cube. So we have x cube, y cube, and from the middle two terms I can take out a 3xy as common, and in the bracket, so inside I'll have x plus y as the remaining term. Okay, so x plus y the whole cube would be x cube plus y cube plus 3xy times x plus y. So x minus y the whole cube will be, so instead of y we put minus y. Okay, so I'll have x cube minus y the whole cube, that will be minus y into minus y into minus y, so that will give me minus y cube. Instead of y, if I put minus y here, I'll get minus 3xy, and this will be x minus y. So when I put x minus y the whole cube, that is instead of y I replace it with minus y, I'll get x cube. In place of y cube it will become minus y cube, and instead of 3xy it will be minus 3xy, and instead of x plus y it will be x minus y. So this is just a short trick how to remember x plus y the whole cube and x minus y the whole cube. If you want, you can derive the formula using the same method also, that is x minus y the whole cube can be written as x minus y times x minus y the whole square, and then follow the same procedure and you can derive the formula. This is just a short trick to remember how x plus y the whole cube from x plus y. If you know this formula, you can remember this formula also. Now let us look at a couple of examples. So we have expand the following cubes, 3a plus 4b the whole cube. So this is x plus y the whole cube. So instead of x we have 3a, and in place of y we have 4b. So all we have to do is substitute x is equal to 3a and y is equal to 4b in the identity x plus y the whole cube. So we have 3a the whole cube, y cube, and that is x cube plus y cube plus 3xy times x plus y. So substituting and cubing, we'll get the answer. Second one is x minus y the whole cube. So instead of x we have 5b, and instead of y we have 3 cube. Okay, so when we substitute x is equal to 5b and y is equal to 3q in the identity, we'll get x cube minus y cube minus 3xy times x minus y. So taking the cubes and multiplying, we'll get the answer. So this is just a simple application of the identities that we have learned. All we have to do is substitute for x and y in the identity. So another example, a numerical example where we can use the identities. Evaluate each of the following using suitable identities. 104 cube can be written as 100 plus 4 the whole cube. So again, this is x plus y the whole cube. Instead of x we use 100, instead of y we are using 4. Simply substitute the identities, cube the numbers and add them, we get the answer. So this Using this method, we can find the answer a bit more easily than using the normal multiplication. Similarly, 999 cube can be written as 1000 minus 1 the whole cube. So this is x minus y the whole cube, x cube minus y cube minus 3xy times x minus y. So here x is 1000, y is 1. So cubing and solving will get the answer. Okay, so this is also another example or an application of the identities x plus y the whole cube and x minus y the whole cube. Another example of the use of identities would be factorization. So we have 8x cube plus 27y cube plus 3x square y plus 54xy square. So when you see such a question, first thing that you have to check is whether you can find two perfect cubes in the polynomial. So here there are two perfect cubes. 8x cube is 2x the whole cube. 3y cube is 27y cube is 3y the whole cube. So if you find two perfect cubes, there is a chance that this identity is of the form x plus y the whole cube or x minus y the whole cube. But in the previous section we had seen factorization using the factor theorem and remainder theorem. So when you see such a question, when it is a cubic polynomial, check whether there are two perfect cubes. Okay, if you find two perfect cubes, then check whether the other two terms are of the form 3 x square y plus 3xy square or minus 3x square y minus 3xy square, or that is whether it is in the form of the x plus y whole cube or x minus y whole cube identity form. Now when you check here, I can see that the other two terms other than the perfect cube terms, they are of the form 3 into the first term x square times y plus 3x square plus 3xy square. Okay, so this is of the identity form, which means this whole polynomial can be written of the form 2x plus 3y the whole cube. That is nothing but 2x plus 3y times 2x plus 3y times 2x plus 3. So when you are asked to factorize a cubic polynomial, first check whether you can find two perfect cubes. If you find two perfect cubes, then check for the other terms if they are of the form in the x plus y whole cube or x minus y whole cube identity form. If they are so, then we can factorize it more easily. If they are not perfect cubes, okay, or you cannot find two perfect cubes, it is better, or the correct method is to use the what we had seen in the previous section, the remainder theorem and the factor theorem methods. Okay, now another identity would be, now consider x plus y times x square plus y square plus z square minus xy minus yz minus zx. So I multiply x into this whole term plus y into this whole term plus z into this whole expression. So when I multiply or expanding, I'll get x times x would be x cube, then I'll have xy square. So oh, when I simplify the calculation, I'll get x cube plus y cube plus z cube minus 3 xyz. All the others will cancel out with each other. So we obtain the last identity, which is x cube plus y cube plus z cube minus 3xyz is x plus y plus z times x square plus y square plus z square minus xy minus yz minus zx. So you'll have to by heart this. This is the last identity. So here we have another factorization. So this is also another example. So if you find another cubic polynomial, And if there are three perfect cubes, okay, here we have x cube is 8x cube is 2x the whole cube, y cube is y the whole cube, 27z cube is 3z the whole cube. So if you find three such perfect cubes, check whether the last term is 3 into the product of all those three uh, terms, that is 2x, y and 3z. So here we find the last term is a product of 3 times the product of the first three perfect cubes. So which means this is of the form x cube plus y cube plus z cube minus 3xyz. So if since this is so, we can substitute the identity. So instead of x we have 2x, y is y, z instead of z we have 3z. So this is x plus y plus z, okay, this format. And x square plus y square plus z square, that will be 2x the whole square, y square, 3z the whole square, then minus xy minus yz minus zx. So simplifying, we can factorize this polynomial as the final answer. So that will be that will conclude our section or our chapter 2 polynomials. So I like you to finish the examples, try the examples and finish the exercises in section 2.5 and 2.6 and send them to me. If you have any doubts, please feel free to message me. Yeah, I guess that's it. Thank you.